It's what we call the home stretch for Christmas break now, right? This is the beginning of it. So let's see what we got. We got 1, 2, 3, 3 full weeks, and then just those 3 days right there, the finals week. So we got 3 weeks left, and then the finals week until we get a long break. And the break's going to be like crazy long, almost 3 weeks there, like 2.5 weeks. So good break coming up. Hope you had a great Thanksgiving time. Man, I had to Google Maps how to get back to school this morning. It was such a nice long break. Got away from everything. Saw family. Man, all my kids were over the house day after day after day during the break. So we had a great time. Played a lot of games. Went to a couple of movies over the break. Ate too much. You know, I had a dental cleaning last week, and they said, "Well, are you ready to eat too much Thursday?" I said, "Hey, I've been practicing all year." So it was good. It was good. Enjoyed it. So fabulous break. All right. Well, we don't want to be here all morning. I got my cyber class after this. So let's take a look at what programming holds this week. There we are. All right. So looking at programming this week, let's see where we're at officially here. All right. So if you are current, that means you have completed the Turtle Graphics assignment, which was just a multiple choice at this point. But we're about to get into some more fun with that. As you can see, we got 3 more assignments and then the final exam left. So for Christmas break here. So this week we have 4 loops. So let's look at the 3.02 lesson on for loops. Close module 1, open module 3, 3.02 for loops lesson. All right. Looping is going to be very useful, especially in graphics, but it's useful in a lot of areas of programming. So you don't have to keep doing the same thing over and over again. It says, doing repetitive tasks might seem repetitive. Yeah, because that's what repetitive is, right? In reality, they make life easier, right? Like bathing in a regular pattern ensures an odor-free self. Pedaling a bicycle over and over helps you propel forward, right? Because you have to do it over and over and over. Like in programming, the ability to repeat lines of code that you're going to use again anyway will save you time and make less work. So we're going to learn about the for loop programming structure and the boundary conditions needed for that. So let's look at these few pages and see what we can learn. All right, so how do you conquer repetitive task in programming? It's easy. You create a loop. Oh, we have a little definition of a loop. Program statements that cause a segment of code to be repeated until a terminating condition is met. Right, because when you have a loop, you want it to loop until something happens, right? Because at some point you want your loop to stop, or else that's one of the errors you can get is you can be caught in a loop that can never get out of. So to make a loop, you need 2 things. You need something to repeat, and then something to tell the program when to stop repeating. So, for example, you understand the code needed to draw a line using Turtle Graphics, but what about a square? Well, there's 2 ways to do that. Let's look at these 2 examples. So without a loop, and we looked at this before the break, so we name our turtle Leo. We tell Leo to go forward 100 pixels, turn left 90 degrees, forward 100 pixels, left 90 degrees, forward 100 pixels, left 90 degrees, forward 100 pixels, left 90 degrees. Man, and that would do it, right? Because there's 1, 2, 3, 4 times that it goes forward 100 pixels before it turns 9 degrees. Another way to do that, okay, Leo equals turtle, not turtle. So we got Leo again. We said for side in range 4. This is a for loop. So you're telling it for a range of 4 iterations, I want you to run the following code. Go forward 100 degrees and turn 90. For side in range 4. That means do this 4 times and then stop. So it'll have the exact same output. So instead of having to write this code 4 times, we just create a loop. Create a loop. We'll get a chance to play with that here too. So, I always encourage you to go into the lesson to where they have the pre-made program and play with it there. See what you can change. So, yeah, imagine writing several hundred lines of the same code. Programming will require you often to repeat code, but to avoid having to copy and paste a million times, we can use these loops. All right, so to use a for loop, we give Python our action. Draw a line, turn left. So let's give it a try. Let's see. It says read the code, try to predict the output, select run program, look at the output. Are the results what you expected? All right, so we're going to look at what they've written. Hashtag for loops, import turtle. Remember, you got to import. If you're going to use turtle graphics, you got to import it. Here's our main function. We name our turtle Tilly, Tilly the turtle. And Tilly is going to be deep pink starting out. So print side 0. Now it's literally going to print what we put in quotes, right? So on the output, it's going to say side 0. Then Tilly's going to move forward 100 pixels and turn left. And then Tilly is going to print side 1, literally print that on the screen. And then she can go forward 100 and turn left. Side 2, forward 100, turn left. Side 3, forward 100, turn left. Main. So we kind of expect to see a square like they just showed us on the previous page, right? Because that's what it was. It was forward 100 and 90 degrees left. So let's run it and see what actually happens. Side 0, side 1, side 2, side 3. There it is. It printed this before it printed each side. It printed the side number, side 0, 1, 2, and 3. We can run it again. 0, 1, 2, 3. So notice the pattern in the code. To draw the square, the turtle repeats the same forward and turn movements 4 times. So the length of the program becomes long pretty quickly. What if we wanted to draw a decagon, right? A 10-sided polygon. We'd have to do this 10 times. So let's go to the next and see what next example. All right. Let's look at this code. Import turtle, define main. Nothing's changed there. Still, Tilly is a pink turtle. All right, this is 4 side in range 4 with a colon. So you got to pay attention to how these things work. There has to be a colon at the end of that. Print side blank, a little blank after side, string side, because we called the loop side for side. So we're going to print what the for loop is on. Is this iteration 0? Is this the first, the second time, which would be called side 1, 3, 4, and we'll see. Because remember, it starts counting at 0. It's going to stop at 4. So let's run this. Side 0, side 1, side 2, side 3. So output looks exactly the same. But instead of doing these things here 4 times, we just created a loop, a for loop. A for loop. A lot shorter. It'd be easy to do 10-sided. In fact, let's have some fun with that. Let's do 10-sided. Let's make it a lot smaller. Like I said, play with this. Let's make it like a length of 30. And if it's going to be 10-sided, we need it to be 36 degrees, right? Because 36 times 10 is 360 degrees. So let's make this a 10 then. Run program. There we go, a 10-sided. It printed it 10 times, starting with 0, ending with 9. When it got to number 10, it stopped because it started counting at 0. But we have a 10-sided figure right there. 36 degrees each time. So you can play with this to figure out how to do these things, see what happens. You know, if we had our range wrong and we only did 8 and we ran that program, then it would stop after our 8th one and we didn't complete our shape. Right. So for 8, you'd have to change the amount of degrees it was going to go to get to 360. And if we go to 9 and go to 40 degrees, 9 times 40 is 360. We can do a 9-sided. Just play with it. Figure out some things about it by doing that. All right, let's look again. Errors. That's a warning us right away. We're probably going to have errors in this. Import turtle, define main. Oh, royal blue this time. 4 side in range 4. All right, so we're doing again a loop 4 times. We're going to again print the side. We're going to go forward 100, left 90, main. So I don't see anything different than than we did last time with the four-sided, other than we're royal blue this time. So let's see, run program. All right, everything's working. Now let's see what instructions give us. Let's explore some common errors with for loops. Try deleting keywords and symbols such as in, range, for, and the colon. Well, let's start with deleting in. For side, range 4. Oh, bad input on line 10 because it doesn't have in. For side in. How about for side in 4? INT object is not iterable on line 10. See, it doesn't know what to do with this here because of that. So this is, notice the errors again. You can kind of figure out what we're missing because you're getting different errors. Let's go back to the range. And if we forget to put the for side in range, run program. Nope. Again, this object's not iterable line 10. It has blank because we didn't give it a range. What if we didn't have the colon? Just bad input. But all of it, now we're working again. Try removing the indentation inside the for block. Yeah, what if we just did this? Oh, silly. Same code, we just didn't indent it. Bad input on line 11. That's this line right here. Again, inside the loop, you have to indent everything that's going to be part of the loop so it knows how to handle that. Back to run that works again. All right, be sure to fix each error before trying another. Select next. So yeah, that's just errors you can get by just leaving little things off. Of course, this isn't an error. If we leave that space out, it just doesn't look as good because it puts the number right up against the side. So you can put that extra space inside the quotes to make that look better over there. All right, let's see what we have over here. Read the code, try to predict the output. So again, we have a main function. Oh, we're naming our turtle Michelangelo. He must be a real artist. And he's going to draw with orange. So we've got an orange turtle. And this time we define side and angle as variables at the beginning. So we're going to say each side is 75, each angle is 90. For count, and this time we're calling it count. Instead of side, we're just, that's fine. How many loops are we going to count? 4. So it's going to go through 4 loops, side, angle. Let's run the program. There we go. We didn't tell it to print this time. Notice there's no print statement, so we don't have anything in the output. We only have the turtle graphics box. It says change the angle from 90 to 95. Okay, so let's change the angle to 95. If we just run it once without any other changes, we just have not quite a square. It says modify the for loop to repeat 40 times. So instead of 4 times, let's go 40 times and see what that does. Wow. Well, now we're making some more interesting looking shapes. So this is going 40 times at a 95-degree angle, all sides being the same length. And it stops right there. Yes, Rebecca.
Is there any way to like make it faster?
That's a good question. That if you make it really something complicated, it could take a long time to draw that. I don't know. We could dig through those commands. Yeah, Daniel.
Yeah, I found a speed command.
Is there a speed? I said we could dig through those commands and see if there's a speed. So how does that work, Daniel? Let's play with that. Do you?
I don't remember exactly.
Okay. All right. Well, we'll look at that. Let me. In fact, let's pull up our Google Classroom here. Since that's a good question, while we're on that topic, let's look at that. So I put the Python commands right there. Here they are. open that PDF. Well, it doesn't want it. There it comes. It's slow, but it's coming. Yeah, Turtle Graphics has a lot of commands that the lesson doesn't get into. See, the Turtle Graphics module's down towards the bottom. So let's go down to way down here a ways. Oh, here's Turtle. Yep. All these Turtle stuff. Radius. Turtle Graphics. All right. Number of steps. Let's see. Radius, circle commands, color, infill, forward, hide turtle. Let's see. Left angle, pin down, pin size, pin up, right angle, set heading, set position. If you want to start somewhere different. Shape value, show turtle, speed. There it is. So it's just like carry.speed.8. So we can put that. Let's look at our program here then. So if we say, I guess we could do that up here ahead of time. Yeah. Before we get to the loop. So if we say Michelangelo.speed.10, let's see what that does. Oh yeah, look at there. That's a lot faster. Great question. And Daniel's already on top of it. So yeah, you can change the speed up to where to go a lot faster. You just have to put that in your defined turtle stuff up here. You define, you name your turtle, tell them what color to use, and you can tell him what speed to go at. So I wonder if that's unlimited. It would say speed 1,000. Oh yeah. Yeah, we can put big numbers on there. 100,000. You can't really tell a big difference. That looked about the same as 10,000. There must be kind of a limit. Not much difference there. So yeah, but you can put the speed on there so you can draw things faster. But yeah, we can play with that. We can make it 400 at a speed of 100. We'll do a lot more. Really fill that in a lot more. 400 loops. Well, that's a lot. It's still going. It's just getting denser and denser. At some point, it's repeating itself because of our angle. It's just making the lines thicker because it's drawing over what it already drew at some point. So, all right, let's look at what else they have. All right, read the code, predict the output. Import turtle, define main. So Leo is our turtle now. And he's blue. Oh, here's our speed example right here in the next one. We were just talking about that. 1090 side plus count times 2. Okay, this is interesting. So we're doing 60 loops. And the side length, how far it's going, is going to be side, which is 10. It's going to go 10 plus whatever the loop is times 2. So the sides are all going to be different lengths, right? And they're all going to have a 90-degree turn. Let's see what that looks like. That's going to be different. Each side is longer than the last one. So it doesn't make a square. It makes this kind of maze pattern. Mesmerizing, huh? See, the count is determining the loop. The count right here is determining how long each side is. So the first one, it just is the same. Like the first one is 0. So 0 times 2. The first one is actually just 10 long. But then the next one, when it's at 1, after 0, it's at 1. So it's going to be 10 plus 1 times 2. So the next one will be 12 long. And then 2 times 2 on the next loop. So 14. So it's 10, 12, 14, 16, 18, 20, 22, 24. It's just getting each time getting longer and longer. Let's see. It's got one more example it wants to play with here. All right. So define main again. Ty. We're just calling our turtle Ty. We got tired of the long Michelangelo names. We're just doing Ty. Ty is going to draw forest green at a speed of 10. Length of 10, angle of 90. Okay, so everything's pretty standard so far. Let's see what we're doing with the loop. Loop 10 times, side of 10, 90 degrees. So it's just drawing the same square over and over again. So it's create your turn, create a turtle and move it in a pattern or shape you're choosing. Octagon or star, make any changes you like to the existing code. So they gave us the basic code to just draw a square over and over again. Let's make it bigger. Let's make it 50. Right. So it's just doing a 50. But if we change our angle, let's see. Let's take an angle of like what do we think? I'm just making up a number. So if we put a lot more loops in that, you can make whatever shape you want. It's just a little bit off. So just play with it. So if we did one of 72 and 5 loops, that would just be a pentagon, right? So this is giving you what to play with. Your turn. Play with the side length, play with the angle, play with the number of loops. You could change the color. Make any changes you want. Move it to pattern, shape your made on star. You change the color if we don't want forest green and we want navy blue. Oh, see if it likes navy blue. There we go. It's a very, very dark. It almost looks black. They're navy. Let's see. Does it have sky blue? Yep, sky blue. So you could use your imagination, but this is the chance for you to get in there and just play with it. Playing with the loop, changing the side, the angles. Yeah, we could do it side plus. Just make it whatever the count is, just adds 1 each time. So it doesn't quite match right there. But we might want to loop it a bunch of times then to do that. So we can really see what it's doing. It's just getting bigger and bigger. A lot of stuff you can play with. You're limited by your imagination. Remember, you got all these commands over here too that you can do stuff on there. Stamp. Leave a copy of its shape on the screen. Well, that's interesting. Stamp. So it leaves a little turtle on there. Tie dot stamp. Was there anything with that? Oh, we just put an empty bracket after that. So, oh yeah, so it left the turtle right there at the beginning because I told it to leave a stamp. What if we put that down inside? Let's take it out of there and put it in our loop. Indent it over. It's going to leave a stamp every time. So it's going to stamp the turtle every time through the loop. That's kind of interesting too. The turtle copies itself every time it makes a turn. Right after it turns left, it leaves a stamp of the turtle on the screen. Anyway, like I say, you can play with all these commands on here. Speed value, all kinds of stuff. And you can work on moving the turtle. Yeah, pin up right there. That lifts the pin. Like you could draw a shape. Let's see, after that loop, let's do this. Oh, let's see, how's that command work? Let's look at the pin up command. So we do your name of your turtle and pin up. So after that, we could say tie dot pin up. And then you could do a different loop. Copy. And then we'll do another loop after that. And we'll call that one count 2. And we'll have it do 20 times. But we'd want to move our turtle first. Where's the set position thing? That was down there. Set position. Okay, so if we did, after the pin up, we did tie dot set position. Is that how that worked? Oh, set POS. -50, -50. I'm just starting somewhere else, and then a loop with pin, and we can set a new angle. Side equals 20, angle equals 44. So let's run that, see what happens. So here's the original one. I probably shouldn't have made that so big because I'm moving. I'm going to draw another shape. It's going to overlap. So it gets done with that. Now it did this. Oh, I never told it to put the pin back down. Oh, yeah. Was that a show turtle? So it didn't draw anything else. I never told it to put the pin back down. There's pin up. Pin size, you can make it thicker. Pin down. So I got to tell it to put the pin back down now. So after I move it, set pin up, move over here, and then I'm going to put my pin back down. So move it over here and then put the pin back down. So draw. Let's go back up and change the side of this smaller. All right, so now let's run it. So I made this shape over here, starting with a 10 this time. And then I made this shape over here. That was the second loop. I pulled the pin up. I moved over here, put the pin down. I could also change the color. I could take this color and make the second shape a different color. I'll do the pin down anywhere in there. And let's say that make this one crimson. And let's do 20 loops. Draw the first shape. Like I say, play with this. You get to do what you want it to do. So then I changed it to crimson and did a whole different thing. But I moved the starting point from over here to -50, -50, which took it over here. Think of this like an XY graph, and it starts at 0, 0. So I moved -50 and -50. I moved it down over here. So if you think of it like an XY graph in math, you can kind of move your starting position. And you can move it farther where it doesn't overlap. And you can make the first shape smaller where it doesn't create a problem either, too. Angle 64. So that doesn't overlap as bad, but I could move the starting position. And I could take off that little turtle that keeps stamping itself, too. That would be, take off that. He doesn't stamp himself every time on that one, but he does on the red one. So lots of options for you to play with to figure out how to use these graphics and to draw what you want to draw. All right, let's look at the next page. For loops and counting. So one of the best things about the for loop is it gives you control over where the repetition starts and stops. When coding a for loop to make a simple square, we said 4 times, 4 side in range 4. We want 4 loops to make a square. But man, they're really drawing something over there that's really different. So the range can be more specific. If you put 3 values in your range, you can specify the starting value, the ending value, and the count. So this says start at 9, go to 20, and count by 3s. 9, 12, 15, 18, and then it'll stop because that's the stopping value. So it only runs until it's less than 20. When it's 20, it stops. So when the loop begins, the counter variable in, because this is what we're calling it in. We didn't say side or count. We said for in. N starts at 9, and after each loop, it adds by 3. Now, that may be useful, especially if you're using this to determine the length of the side. Add whatever loop we're on. Okay, add 9, add 12, add 15, add 18. That's when you might want to use something like that. So the loop in would have the values of 9, 12, 15, and 18. So it's still just loop 4 times. Because we told it to start at 9 and go by 3s. So that gives you a little bit more flexibility on how to play with your loops. If you can tell it not just count by 1 and don't start at 0. All right, last page. Oh, another example down here. As you're seeing, programming a large amount of code involves using repetitive statements. take a long time to write if it wasn't for these loops. So from basic calculations and math to more complex systems to make everything easier. Let's look at some more stuff here. Read the code, try to predict the output. Define main, print, I can count. And look, we do a loop. We call it in. We start with 0 and we stop when we get to 10 and we go by ones. And we're counting Mississippi's. All right. And we're going to actually just print what the value of the loop is. What loop are we on? We're going to start out on loop 0. So what do we expect? We expect this to print 0 Mississippi, 1 Mississippi, but it will not print 10. 10 that says when you get to 10, stop. Don't do anything. So let's run it. I can count 0 Mississippi, 1 Mississippi, 2 Mississippi, 3, all the way down, and 9 is the last one it prints. Because when it gets to the 10, that tells it, oh, don't loop anymore. You're through looping. Go on to the rest of the program. Stop this loop and just go on to whatever's next. Well, what was next was ending our main function, and the program was done. All right, so it doesn't count from 1 to 10. It says modify the range so the count is from 1 to 15. Okay, so we can tell it to start at 1 and go by ones. But if we put 15 here, it stops at 14. Remember, this is the value when it says don't loop anymore. So if we want to count from 1 to 15, which we did start with 1, we didn't start at 0. We tell it to stop when it gets to 16. Don't do 16. Stop when it gets there. So now it says I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 15. So that's what's important to remember in your loop is that this is not the number of loops necessarily, unless we start at 0. If we start at 0, then yes, it will do 16 loops. But 0 to 15 is 16 loops. But you can play with starting value, ending value, and the step value of what you want it to do. All right, let's see what other example it's got. Read the code, predict the output. So back to the turtle, importing the turtle. Trevor's our turtle this time, and he's a royal blue turtle. And he's going at a speed of 10. So for end and range. So we're starting at 5 and going by ones. And we're going to stop when it hits 25. So, and we're going to print what the value of the loop is each time. So it'll tell us 5 is our first loop. All right. And then he's going to go forward 100 plus the loop number. And he's going to make a left-hand turn. So this is going to be one of them maze-looking, square-looking mazes. Yeah. But it almost looks like a picture frame. They're so close together. Because it's only adding 1 each time. So it's just 1 longer than the last line. So that's why it looks so close together like a frame. Got kind of neat look to it there. Making it very thick. So what happens if you subtract the value of n from 100 in the forward function? Oh, that's an interesting thing. Instead of adding 100 plus n, let's do 100 minus n. So now it'll make it where it's getting smaller and going in instead of getting bigger. Because we subtracted the value of n. So you can play with all these type of things. All right, let's look at number 3. Print the countdown. So this is starting at 10 and going to 0. And it's going -1 as a step count. See? The countdown, 10, 9, 8. We told it to print 3 dots out in the front. That's why those dots are there, because we added that to our print statement. And then after it's through, look, here's the loop. It says do this from 10 until it gets to 0. And then it gets out of the loop and prints. So I'm done with the loop. Go do what's next. What was next? Printing blast off. That's what was next. And that was the end of the program. So at the bottom, it does something different because that's after our loop. Notice the loop has everything indented. Everything indented is going to be part of the loop. If we indented this, oh, let's see what that does. Look at that. Now that's part of the loop. It prints blast off every time. 10 blast off, 9 blast off, 8 blast off, because we indented that. So if you don't want it to be part of the loop, it should not be indented. All right. Now let's see what this says. define main. We've imported our turtle up here. We're calling him Tate. Tate the turtle. If you have a turtle, you can use your turtle's name. You know, like some people have turtles. My son-in-law's sister has a turtle that goes with her everywhere. It's her support turtle. I don't get it. Tate color. This is a maroon turtle. Tate's maroon. He goes at a speed of 10, and he's going to start at negative 30, 30. So instead of in the 0, 0, it's going a little higher on the left. So it's going to go a range from 25 down to 0 because it's going negative 1. Notice, let's see, if we leave that just a 1, what's going to happen with our loop now? We tell it to start at 25, stop when it gets to 0, but we made a mistake and said count by 1 instead of negative 1. Oh, let's see. It did one thing and stopped. Did one thing and stopped. It didn't work like we wanted to. Put negative 1. Now when we run it, oh yeah, now it's doing just really wild star pattern. We didn't do enough loops to complete the star totally, or we have the angle we may need to change. But the angle it's turning is 180 minus whatever loop number we're on. So first it was minus 25. Then it was minus 24. So our angle changed every time. So it's not going to make a perfect star because every angle is smaller than the last angle by 1. Going down negative 1 every time. So 25, 24, 23 is subtracting that. To the last angle, see, it was almost 180. Almost 180 because it got down to where it subtracted 1 the last time. Now it's at 0. So, all right, let's see what the last example they give us here. Read the code, predict the output. Okay, 4 loops, define main, total equals 0. Print, I can count by 5s and add them up. Okay, that's ought to be interesting. So it starts out setting a variable called total, and it sets it equal to 0. And we're going to do a loop from 0 to 100. Notice we're stopping when we get to 101, but it will do loop 100. And we're going to count by 5s. So the first number it's going to have is 0, but it's going to add 5 every time. And we're calling it n for n, number, n. So the total is going to equal the total plus whatever n is. Starts at 0. So it's going to start the first time. It's going to take 0 plus 0 because that's where we're starting it. So it's going to print just whatever number it is, 0. And then it's going to loop back again. And it's going to change it to 5 now because it's going up by 5s. So it's going to take whatever the total was, which is 0 plus 5. So now it's going to have a 5. And then it's going to take the total of 5 and add the next number, which is 10. And each time it's going to print the number, say, okay, for number 10. And at the bottom, it's going to total is, because every time it's calculating, what's our total? And we're going to print it at the bottom. So let's run this. 0, 5, 10. See, there's the loop number. So we told it to print whatever loop number we're on as a string, whatever loop number. We were in loop 0, then we were in loop 5, then 10, then 15. And each time it prints which loop number. And it's adding that to the total each time. So at the bottom, we should have the total of 0 plus 5 plus 10 plus 15, 20. The total is 1,050. If you want to get your calculator and verify the computer, you can do that. But that's a way you can do 2 things at once. It's printing which loop it's on, and it's keeping a subtotal all along, or a total all along, of adding each loop to itself. See, this time there's a small twist to the change of our loop. The change value is set to 5, counting variables incremented by 5 each time, and calculating the total during the loop. So it takes some time to do it with the calculator, but you can write a little program to add up all these numbers for you real easy when they're sequential numbers. These are sequential by 5, 0, 5, 10, 15. And this little program will add that all up for you. So last example here, number 6. Import turtle. Taya the turtle. With a speed of 10. Pin up. Move over to 080 to start. and then put the pin down. And we're going to do a loop. Starting at 2 and stopping when we get to 26. It's going to go by ones. And we're going to start out with the aqua color. And we're going to go forward 10 and right 15. So 15-degree angle every time it goes 10 pixels. Then we're going to go to dark orchid. Like I say, it's got a wide range of colors. Whatever you can think of, it's probably in there. And it's going to make a circle of radius 5. And it's going to do this every time. It's going to loop, go forward, circle, forward, circle. Let's see. Let's see what it looks like. Now, see, it's moving that little blue line. You can hardly see the aqua color. Aqua color is kind of tough to see. Let's change that to a green or something. Yeah, we can see the green a little bit better. Make it a dark green. And let's make it a little bigger. Make it go 20 and make this 10. We'll make it bigger. There we go. We can see it. So every time after it moves forward 20 pixels, it makes a circle of radius 10. And it loops back here again. Notice all of this is indented. So after the circle, it loops back up here, changes it back to dark green, moves forward another 20 after a 15-degree turn, and it makes another circle. Radius 10. Loops back up here, turns it back to dark green, goes forward 20, turns 15 degrees, does another circle, loops back up here, over and over and over. Let's see, what if we went 252 here? Let's see. Would it be different if we went by 2s and doubled the range? No, it's pretty much the same thing because we just told it to count by 2 this time. We're not using n to determine the length or the angle. So what happens if you change the range to increment by 5? Well, let's see. If we change it to 5s. We end up a lot less circles because when you're counting by 5s, we're going to get to 50 a lot faster. So really, if you want to try something, go into the lesson here and play with this, or you can copy this into a idle window and play with it there. All right. I can copy that, open up an idle window. So you can just take the whole thing in there and then play with it. Move it over where you can see your turtle there. So, yeah, easy way to get your program started. All right, let's look and see what our assignment is this week. Follow the assignment template. I need to double check, make sure I got the template in there. I'm pretty sure it's already in Google Classroom. I think I should just look right here. Let's close that. Week 15, programming. Oh, there's our template. We do have the template. All right, so the template is going to look just like this here. All right, decide on a repetitive pattern or the outline of a shape. Like you could draw a house, you can make a box, and then you can go up and move your turtle up and draw a roof, and you could draw a door. You can play a lot with that. Remember the pin up and pin down, where pin up and move it and then pin down. Give your artwork a name, print the name. Oh, mom. So this is part of what we need to do. So first you're going to print your name. Then you're going to use your for loops and draw an outline of a shape or a pattern, whatever you want to draw. Name it, then draw it. And you have to use at least one for loop. And it should repeat at least 3 times. It'll probably repeat more than 3 times, depending on what you're drawing. I mean, even a square has to repeat 4 times, right? So, and use one color other than black. You can use black, but make sure you use another color as well. And write your pseudocode. Right? So put your pseudocode right there on the template. All you're going to do is give your artwork a name and then draw whatever you want. If you want to draw a square, draw a square, but try to be have more fun with it than that. You know, we saw some pretty cool different little patterns than what we were doing there. You could do flowers or different things. Whatever you want to try to do, get as creative as you want to. Have fun with it. There's nothing there's not a pattern you draw that I'm going to count wrong. Oh, no, that's the wrong pattern because you're picking the pattern. You're drawing what you want to draw. So here's someone that kind of drew a little basic little house. You can make it as basic as you want to or as fancy as you want to. Here's someone that just did one of these spiral patterns. That looks pretty cool. Notice they changed colors in there. Some of it's yellow, some of it's red. Right? So put your pseudocode and then your actual code and then the 4 questions. The 4 questions. Don't forget your 4 questions. Pseudocode, code, 4 questions, and you're just having fun with it. So, all right, that's your lesson for the week. That's your assignment for the week, guys. All right, you know what you got to do. So I'll let you guys go. Got my cybersecurity folks coming in here now, so I'll go to change the cybersecurity class. But if you got questions, email me. I think this is a B day. Let me double check that real quick before I let you go. A day. That's wrong. It's an A day this week. Okay. So A day on Friday. So I'll be here Wednesday and Friday. If your grade's below 70, I'll see you Wednesday and Friday. But if it's above 70, it's an option. We'll see you then. Have a great week, guys. Have some fun with your turtles.